bent space. This is a difficult concept to come to terms with. We are too used to the space and flow of time around us. Nine years after his happiest thought, Einstein published a paper about gravity. His special theory of relativity was child's play compared to gravity. Now, let us enter into Einstein's mind. I am affected by gravity inside the spaceship. It's the same with a spaceship hanging from a line. This is the same thing as acceleration. I am standing inside a spaceship hanging in the air. Like the spaceship on the ground, I am being affected by gravity. But the situation changes when the line is severed.
상황은 달라집니다.
As the spaceship falls, gravity disappears. If I push an apple in a place without gravity, it moves in a straight line. My state in the spaceship is the same as being in zero gravity in space. So, what happens if the spaceship accelerates? The apple will fall. It bends and falls because the floor of the spaceship rises. So in actuality, it is not the apple that falls, but rather the spaceship that rises. This is the same with light. Light also bends. A place affected by gravity is the same as the inside of an accelerating spaceship. Therefore, light also bends. The space surrounding an object that has weight bends. This is the same thing with the space around the sun. Although the light from the star behind the sun is traveling in a straight line, it passes through a bent part of space. The reason that Eddington was able to photograph the stars that were blocked by the sun was because the light from the stars bent as well. Gravity is not a force that pulls. Rather, it occurs because space bends. This was Einstein's answer. Why do we fall? This is because our bodies follow the bending of space, created naturally by the Earth's mass.
Eddington was director of the Cambridge Observatory in the time after the First World War, and he began to hear about the theories of Einstein. And one of the predictions of Einstein's theories was that the light from distant stars would be bent or deflected by the gravitational field of the sun. And Eddington decided that he could actually prove this if he went on an eclipse expedition and measured that deflection by taking a photograph of the sun during eclipse. And so in 1919, he went to a small island off the coast of Africa for the very rare event of a total eclipse of the sun.
Even now, eclipses draw throngs of curious people. As the eclipse was occurring, Eddington observed that starlight bent around the sun, just as Einstein predicted. On May 29, 1919, Eddington published his photographs in a paper. The curtain had fallen on the age of Newton, and a new age had dawned. Einstein became famous throughout the world. In 1930, Einstein met with Eddington here at the Cambridge Observatory. It was the moment that the creator of a great theory met with the person who proved it. Thus, the general theory of relativity was born. But this magical story is not yet over.